Good day, everyone. I'm Sharan, and I will be your moderator for today's webinar. On behalf of Beroe, I would like to welcome you all for the second webinar from Beroe Insights for this quarter and year 2014. So, the topic for today's webinar is to understand and discuss the strategy to ensure eco-friendly mining practices through utilization of electric vehicles. So before we move ahead with the presentation, I have some general set of instructions as always. Please note all the attendees will be placed on mute. And during the course of the presentation, if you would like to post any questions, you will find a box on the right-hand side that is indicated in red on your screen. I request you to type your questions and hit the send button. And as the presentation progresses, I will note down the high-frequency questions and will ensure to post it to the presenter at the end of the session. If you're experiencing any connection issues, I request you to close the window, go back to the email, and try to connect using the same link. If there are further problems, I request you to email Puneet at puneet.ramal@beroe-inc.com, and you will find his email ID in the invite that has been sent across to you. Moving on, let me quickly introduce the speaker for today's webinar. He's Sabrish Vaishnav, Research Analyst, Mine Production Consumables category at Beroe. He has worked on several research projects, reports, and assignments for multiple top mining companies of the world. So, without further ado, let me pass it on to Sabrish to take you through the presentation.
Thanks a lot, Sharan. Good day to everyone. Once again, thanks a lot for joining this webinar. Often, there is a belief that sustainability is not a term to be spoken with mines or mining companies. But the truth lies in the fact that there are opportunities and areas where mining companies could make their operations more sustainable. So today we are going to discuss how utilization of electric vehicles can bring about sustainability and can also bring about cost effectiveness. As we are aware, underground mining is a process wherein we extract valuable minerals out of the deep-seated ores located at greater depths, for which mining companies utilize sophisticated equipments such as load haul dumpers, drilling rigs, excavators. Majority of these equipment utilize diesel as the major source of energy. In the past, mining companies have been utilizing diesel vehicles for their underground mining operations. But now there has been an increased shift towards utilization of electricity as the major source of energy. In today's webinar, we are going to discuss and analyze the reasons, factors, challenges, and further on discuss about the benefits of utilizing electric vehicles. Initially, I would be taking a couple of minutes to talk about the operational aspects of diesel vehicles and the subsequent challenges that mining companies would face through utilization of diesel vehicles. And further on, discuss about sustainable mining through utilization of electric vehicles, wherein we'll arrive at a comparative assessment between electric and diesel vehicles. And then we look at feasibility of transition from diesel to electric vehicles and the possible challenges that mining companies would face while adopting such a technological shift. And finally, we'll look at the factors that are expected to drive electric vehicle utilization and a futuristic outlook. For the research purpose, I have considered a load haul dumper LHD, as the case of our study here, as load haul dumper accounts for majority of underground mining population. For ease of reference, I would be referring load haul dumper as LHD. As we are aware, diesel vehicles emit extreme emissions that are carcinogenic in nature. Utilization of diesel vehicles in underground mines can pollute the overall mine working climate. There have been several reports released by various health organizations that keep track of a mine worker's health and safety aspects. And in one such report published by Mine Safety Health Administration reveals that in 2012, around 1,000 mine workers were detected with lung cancer across underground mining operations in Western Australia. Elaborating on that, a diesel vehicle emits carbon monoxide, nitrous oxide, and particulate matter emissions. Although there are special kinds of equipments such as diesel particulate filter that are known to reduce such emissions to a certain extent, however, they haven't shown a significant improvement in completely eliminating such emissions, and thereby raising question of whether is it really beneficial to still use them. In the recent past, I happened to study a news article from Australian News where Mr. Peter Green, a retired mine safety inspector who had worked across underground mines in Western Australia, referred diesel emissions as critical than asbestos. In fact, in 2012, World Health Organization termed diesel emissions as a definite carcinogen. In order to dissolve such diesel emissions, underground mine requires a complex ventilation system. The complex ventilation system can be an integral cost component as it accounts for around 40 to 50% of a total mine's energy requirement. Moving on, a diesel LHD also requires preventive breakdown maintenance on a regular basis. Diesel LHDs requires breakdown maintenance in the form of application of fluid on hydraulic parts and check on PM levels. So if you consider a 10-ton diesel LHD, it can account for a maintenance time of around 3 hours per day, thereby impacting the overall availability by 15% in comparison to its full potential. Finally, the nature of the fuel itself is combustible, and carriage of such fuel to mine faces can become complicated in case of harsh mining environments. In most of the cases, diesel fuel is carried by manual labor, and this adds up to the labor cost, which can finally impact the overall mine operational cost. Having discussed about the operational aspects of diesel LHD and the subsequent challenges that mining companies would face through utilization of diesel LHD, let us look at what an electric LHD holds. A very important point that I consider should be highlighted is sustainable mining. Let's first look at the benefits of electric LHD. The major advantage is that electric LHD do not emit diesel emissions as seen in a diesel operated LHD. And it does not end there. It eliminates the need to have diesel particulate filters and the related spare parts as seen in a typical diesel operated LHD. It also helps in maintaining optimal oxygen content. If you consider underground mine, the optimal oxygen content should never dip below 17%. and the same can be ensured through utilization of electric LHD. Finally, the electric LHD eliminates the need to have a complex ventilation system, thereby resulting in significant cost savings in terms of ventilation. Electric LHD is associated with reduced noise and vibration. If you look at a 10-ton electric LHD, it emits noise levels of around 30 decibels, which is 60% lower in comparison to its diesel equivalent. Also, the reduced vibration enhances operator comfort and safety. Electric LHD requires reduced life cycle maintenance. If you look at the electric LHDs that are currently prevalent in the market, they don't have rechargeable batteries, and so the cable system that is mounted on back of the electric LHD needs to be plugged in all the time in order to ensure continuous operation. So the cable system maintenance checks is required on a daily basis, which can account for 1 hour per day. If you look at the engine maintenance, a 10-ton electric LHD requires engine maintenance for every 500 kilometers of operational coverage, as against for every 125 kilometer required in case of a diesel LHD. Now, coming to the major advantage, electric LHD has higher operational efficiency. In order to understand this better, let me take you through a performance assessment wherein we compare a 10-ton electric and diesel LHD. And what we were able to observe is that a 10-ton electric LHD's production per hour is 25% higher in comparison to a diesel LHD. Yes, it's indeed a higher productivity in case of a electric LHD. Now, how do you say that the electric LHD can offer higher productivity? Let me take you to the parameters that we have considered. If you look at the bottom of the slide, I have considered supporting factors for my performance assessment. If you look at the available time for production, electric LHD, since it requires reduced breakdown maintenance, it can account for 19 hours per day, which is 11% higher in comparison to a diesel LHD. Moving on, if you look at production per trip, having considered a load haul dumper machine with 10 ton, taking into account the fill and swell factor, the estimated bucket capacity for diesel and electric LHD amounts to 7.5 tons. If you look at the speed, electric LHD is having a higher speed of around 25 km per hour. This is due to the light weight of electric LHD, and it has better speed transmission engagements. So the speed is around 40% higher for an electric LHD in comparison to its diesel counterpart. Due to the improved speed, if you look at the number of trips that is made per hour, electric LHD's number of trips is around 10 trips per hour, as against for 8 trips in case of a diesel LHD. So what happens to the production per hour is that a 10-ton electric LHD results in production of 75 tons per hour, which is 25% higher in comparison to its diesel counterpart. While a lot of benefits could be discussed theoretically, a comparative assessment between electric and diesel LHD can further enable us in better understanding of why substituting a diesel LHD by electric equivalent is more a viable option. So if you look at the technical parameters here, considering the energy consumption, a 10-ton electric LHD consumes around 6 kilowatt hour for 1 ton of material handled, which is 70% less in comparison to its diesel equivalent. If you look at the ventilation requirement, as discussed earlier, electric LHD requires basic ventilation system, and a 10-ton electric LHD requires around 4.5 cubic meter per minute for 1 ton of material handled, which is 80% less in comparison to diesel LHD. Coming to the economical parameters, if you look at the capital cost, a 10-ton electric LHD's capital cost is around USD 1.1 million, which is 37% higher in comparison to its diesel equivalent. On the other hand, if you look at the operational cost, it is electric LHD that is advantageous than diesel LHD. For the operational cost assessment, I have considered LHD of 10 tons capacity with an expected lifespan of 5 years of operation. Looking at the ventilation cost, a 10-ton electric LHD can account for ventilation cost of USD 0.74 million throughout its 5-year operational time, which is 64% less in comparison to a diesel LHD. Similarly, if you look at the energy cost, utilization of electric LHD can result in cost savings of around 35%. On the contrary, if you look at the maintenance cost, due to higher costs of the spare parts that is involved, and looking at the current market scenario, it is highly consolidated with very few manufacturers, and so the spare part availability becomes a key challenge. So considering the maintenance cost, a 10-ton electric LHD is 37% higher in comparison to its diesel counterpart. Having considered all these factors into account, the net operational cost savings for a 10-ton electric LHD is 36% in comparison to its diesel counterpart. So what we infer from this is that if you look at the total cost of ownership, a 10-ton electric LHD accounts for USD 3.98 million, which is a definite 25% decrease in comparison to its diesel equivalent.
Sabreesh, so far I think you've given us an insight into the electric LHD and a fair background of what and how efficient it is. Could you throw some light, or what's your point of view regarding other underground mining equipment? So could you just share your thoughts on that, please?
Definitely, Sharon. That's an interesting question. If you consider underground mining operations, equipment with lower material handling capacity have a higher degree of susceptibility in comparison to equipments with high material handling capacity, as the latter part incurs higher power consumption, resulting in higher power costs. If you look at the excavators of operational weight of around 1.5 to 2.5 ton electric vehicles, they do exist in the market and they are prevalent. If you consider mine trucks, since they have higher hauling capacity, the potential to utilize electricity is limited. Having said that, in the current scenario, hybrid diesel electric mine trucks do exist in the market.
Thanks, Sabreesh. I think it does give an insight as to how you look at different mining equipments and how LHDs stand out as an important equipment that a mine should focus when they are actually moving on to be more of focusing on sustainability as an option, or turning their operations to be more sustainable. Thanks, Sabreesh. Move on.
So coming back to the presentation, Now that we have discussed about multiple parameters wherein we saw benefits of electric LHD over diesel, what we need to understand is that change is something that's always going to be constant. And there is an important question that is ringing in our minds at times of technological shift, which is about feasibility. Is it really feasible to replace diesel LHD by electric LHD? Let me first take you through the possible challenges that mining companies would face while transitioning from diesel to electric. The major challenge is to have a supporting infrastructure. The supporting infrastructure comes in the form of substations and charging points. As electric LHD requires uninterrupted power supply, they require charging points to be placed at frequent intervals throughout the mine phase in order to ensure continuous operation. In order to have a supporting infrastructure, mining companies do need high access to capital. Here, the targeted pool is often intermediate and junior miners because in most of the instances, intermediate and junior miners are deprived of high access to capital. As electric LHDs require uninterrupted power supply, it reduces the operational range, mobility, and maneuverability of the machine. Incorporation of long cable systems at back of electric LHD is not viable option, as long cable systems are more susceptible to damage, and it also adds up to the overall weight of electric LHD, thereby resulting in a reduction in speed, which can impact the final production capacity. So in ideal scenario, it is beneficial to have cable systems that do not exceed 200 meters in length. So short cable systems can require periodic relocation of charging points, which can further increase faulty occurrences in cable systems. Now that we have discussed about the possible challenges that mining companies might face, coming to the question of feasibility, if you look at brownfield operations, which are expansion of the existing mines, a higher capital could be incurred at times of alteration of the existing infrastructure in order to support electric LHD operation. And it also requires the existing diesel fleet to be completely replaced, which is not a viable option. On the other hand, if you look at greenfield operations, meaning the fresh mine explorations, deployment of electric vehicles is viewed as a single-time investment, and hence greenfield operations have higher level of feasibility in comparison to brownfield operations. Having discussed about the possible challenges that mining companies would face through incorporation of such a technological shift, let's look at possible solutions that might help mining companies in confronting such challenges. One of the solutions could be through provision of electric vehicles incentive program by the government. In the current scenario, such incentives are majorly available for on-the-road vehicles, but in countries like Canada, such initiatives do exist. There is an initiative called the Green Mining Initiative, which was launched by Natural Resources of Canada in consortium with a group of Canadian mining companies. And the consortium encourages sustainable mining techniques by providing funds to mining companies coming up with sustainable mining operations. At present, around 55% of the Canadian mining population is aligned towards green mining initiative. Another one potential solution could be through provision of operational and financial leasing agreements. Such kind of agreements do exist among diesel LHD manufacturers, and if similar kind of agreements are made available for electric LHD vehicles, it would in fact help junior and intermediate miners in sourcing eco-friendly vehicles irrespective of their higher capital cost. One major solution could be through incorporation of rechargeable lithium-ion batteries. So incorporation of rechargeable batteries can increase the operational range and mobility of the electric vehicle. And it does not require the entire cable systems to be continuously plugged in, thereby eliminating the need to have cable system maintenance on a daily basis. And so this could impact or further increase the available time of production. And since it increases mobility and operational range, further increase in production can be achieved through rechargeable battery-based electric vehicles. Such rechargeable battery-based electric vehicles are currently in research and development, and major equipment manufacturers are expected to launch such sustainable vehicles in the coming years. Even though there are going to be possible challenges that mining companies might encounter while undergoing a transition from diesel to electric, mining companies are still focusing on utilizing sustainable operations in their underground mines. Is it only because of the benefits of electric LHD over diesel, or is it about managing the overall emissions? So what are the factors that really drives electric vehicle utilization in future? This takes us to emission standards. First, they were viewed as norms, and now, due to the increasing level of stringency, such emission standards are a definite driving factor that would drive electric vehicle utilization in the coming years. The US Environmental Protection Agency and the European Union formulated a set of regulations known as the tier or stage regulations. So if you look at the graph here, nitrous oxide levels are indicated on the y-axis and the particulate matter levels are indicated on the x-axis. If you consider the year 1996, this is where Tier 1 regulations came into picture. And the Tier 1 regulations restricted nitrous oxide levels to 9.2 gram per kilowatt hour and the particulate matter levels to 0.54 gram per kilowatt hour. And as Tier 2 regulations came into picture in 2001, it further mandated the reduction in nitrous oxide levels from 9.2 to 6.4 gram per kilowatt hour and particulate matter emissions from 0.54 to 0.2 gram per kilowatt hour. And this is the period wherein diesel engine manufacturers invested a lot in their research and development to develop engines that are compatible to such stringent emission regulations. As the emission standards advanced, considering the current scenario, we are in Tier 4 regulations, which is divided into Tier 4 interim and Tier 4 final regulations. So the Tier 4 interim regulations restricted nitrous oxide levels to 2 gram per kilowatt hour and the particulate matter levels to 0.02 gram per kilowatt hour. And currently we are in Tier 4 final regulations, which were launched by US Environmental Protection Agency last month, January 2014. and it further demanded a decrease in nitrous oxide levels from 2 to 2.4 gram per kilowatt hour. And the period of 2011 to 15, this is where utilization of electrically operated vehicles started to gain importance. So what we expect in future is that with Tier 5 regulations expected to pitch in by 2020 and might mandate the complete elimination of nitrous oxide levels and particulate matter emissions. And hence utilization of electrically operated vehicles is more of a viable option as they do not have such diesel fumes and are completely compatible to such stringent emission regulations. Since now we have discussed about the factors that are expected to drive electric vehicle utilization in future, it is equally important for us to get a glimpse into the existing supply landscape of electric LHD. Looking at the current scenario, the global load haul dumper count amounted to 11,750, out of which electric LHD accounted for 5%. In 2013, electric LHD count in operation amounted to 620. If you look at the existing supplier base, it is highly consolidated with major manufacturers such as Atlas Copco and Sandvik accounting for major market share of 95%, while small-scale Canadian and Chinese manufacturers account for the remaining market. So, having discussed about the supply landscape, now what we expect in future. Moving forward, the important factors that are expected to drive electric vehicle utilization is, if you look at the first factor, the emission regulations. With Tier 5 regulations expected to pitch in by 2020 and would mandate complete elimination of nitrous oxide and particulate matter emissions, this would certainly drive electric vehicle utilization in the coming years. Coming to the second factor, fuel. Diesel fuel is known for price fluctuations more frequently, and this in combination with an expected supply crunch, fuel is also expected to be a factor that would impact electric vehicle utilization in future. Coming to the final factor, which is productivity. As discussed in the previous slides, electric LHD can result in higher production of around 25% in comparison to a diesel LHD. And also, electric LHD is susceptible towards automation.
So, Sabresh, I have just one question here. So you did just now mention saying that electric vehicles are more susceptible for automation. So could you just give some inputs as to how do you think that's going to help with automation?
Yes, sure, sir. So if you look at the future mining scenario, continuous mining is the key to ensure higher productivity, and the same can be achieved through automation. As mentioned earlier, electric LHD requires lesser breakdown maintenance, and it also has improved speed, which ensures continuous mining operation that increases its susceptibility towards automation.
Yeah, I think this gives a clear picture connecting back to what you had mentioned earlier in terms of how the overall productivity is impacted with respect to using electric LHDs. So it significantly shows how it is also going to impact and how it is also going to make automation more susceptible. Thanks, Sabresh.
Thanks, Sharan. Having taken into account all these factors, the emission regulations, fuel, and productivity. Electric LHD utilization is expected to increase in the coming years. If you look at the graph here, by 2015, electric LHD count is expected to account for 8% of the global LHD count. And taking into consideration the year-on-year increases and the factors expected to drive electric vehicle utilization, by 2020, electric LHD count is expected to account for a significant 20% of the global load haul dumper count. So during the course of webinar, we have discussed benefits, challenges, and the factors driving utilization of electric LHD as a significant replacement to diesel LHD. We understand and foresee that electric LHD utilization will turn out to be a successful strategy to increase productivity and achieve better cost savings, thus helping mining companies achieve sustainable mining operations. Thanks a lot.
Thank you, Sabarish. I think so far you have provided us an insight into the key objective of the webinar, thus showing how electric LHDs are going to make a significant impact in the coming years, more to do with an eco-friendly, sustainable mining operations, which would be a welcome change for most of the mining companies. So this brings to the presentation from our presenter today. However, we have a couple of questions which I have taken note of, which had just come up from our audience during the course of the presentation. So the first question that we have for today, Sabarish, so the question here is, the commodity supercycle is known to take effect in mining activities. So have you considered commodity supercycle into account while forecasting the electric LHD utilization in future?
Yes, I have taken into account the commodity slump that took place in 2009, 2010, and the most recent commodity slump that occurred in 2012 and went on till third quarter of 2013. And we have also taken into account exploration spend, a major factor that can affect the demand of mining equipment. The exploration spend dropped by 29% in 2013 in comparison to the previous year. So yes, all these major factors have been taken into consideration and they are expected to impact the equipment market growth rate, including the electric load haul dumpers.
Okay, Sabarish, so let's move on to the next question that we have from our audience. Considering a consolidated market for electric load haul dumpers, who do you think has a better command in terms of pricing? So could you give your thoughts on the same, please?
Yes, sure. Since the market is highly consolidated, ordinary equipment manufacturers are expected to have higher degree of negotiation power over our customers, such as mining companies. But if you consider from a major miner perspective, since the procurement quantity involved will be huge, and if you look at the nature of the contract tenure, it is long, and so they will have higher degree of negotiation over suppliers. Whereas if you consider from a junior miner perspective, they would not possess such advantage as the major miners do.
Thank you, Sabarish. I think that did give an insight into the question that we had from the audience. So these were some of the key questions that we had from our audience today, and we do have a couple of simple questions for which we will ensure to send across appropriate answers by email. So that wraps up our presentation for today. Thank you, Sabrish, for the presentation today. And thanks one and all for being part of today's webinar. Until we meet next time, thank you. Have a great day. Bye.